Hello everyone and welcome to my YouTube channel. Today we want to solve this nice equation. 6 to the power of 2a plus 6 to the power of 4a is equal to 20. And the first thing we are going to do is to rewrite this equation as 6 to the power of 2a plus 6 to the power of 2a times 2, and that is equal to 20. We know that if you have a number x raised to the power of nm, then that is the same as x raised to the power of n power m, and that is also the same as x raised to the power of m everything power n. So we want to use this rule to rewrite our expression, and if we do, we are going to write 6 to the power of 2a plus 6 to the power of 2a power 2, and that is equal to 20. At this point, I want us to let 6 to the power of 2a be equal to x. So we let 6 to the power of 2a be equal to x. And if we substitute x back to our expression, we will have x. So 6 to the power of 2a becomes x, plus 6 to the power of 2a squared therefore becomes x squared, and that is equal to 20. So our task at this point is to rewrite this quadratic equation as x squared plus x minus 20 is equal to 0. So this is a quadratic equation that we can solve easily by factorization. So this we can rewrite as x squared plus 5x minus 4x minus 20 being equal to 0. And of course we can factorize this into x plus 5 minus 4 into x plus 5, and that is equal to 0, which means therefore that x minus 4 multiplied by x plus 5 is equal to 0. And if that is true, then either x plus 5 is equal to 0 or x minus 4 is equal to 0. Let's start with the first part of it, where x plus 5 is equal to 0. Now, if x plus 5 is equal to 0, it means, therefore, that x is equal to negative 5. But remember, at this point, we let 6 to the power of 2a be equal to x, which means, therefore, that 6 to the power of 2a is equal to negative 5. And to be able to solve this, we have to take logs of both sides. So we'll have log of 6 to the power of 2a being equal to log of negative 5. And we can already tell that we have no real solutions here because the log of a negative number is undefined. And of course, that now means we have no real solutions. We want to try the other bit where x minus 4 is equal to 0. And if x minus 4 is equal to 0, it means that x is equal to positive 4. Again, remember, we let x be equal to 6 to the power of 2a. And so we can say that 6 to the power of 2a is equal to 4. Now, if we take the logs of both sides again, we will have log of 6 to the power of 2a being equal to log of 4. And we know that if you have log a power b, then that can be written as b log a. That can be written as b log a, which means, therefore, that log 6 to the power of 2a can be written as 2a log 6, and that is equal to log of 4. Now, for us to get a, we will have to divide both sides by 2 log 6. So I will go ahead and divide both sides by 2 log of 6, 2 log of 6. And of course, you can see that 2 is cancelling 2. Log 6 is also common. We will have a on the left-hand side, and that will be equal to log of 4 over 2 log 6. Okay, so we want to do that up here. We'll say a is equal to log of 4. Let's choose to write it as log of 2 squared. Of course, 2 squared will give us 4, and that is divided by 2 log of 6. And we've already seen that if you have log a power b, then that can be written as b log a. So log 2 squared will be rewritten as 2 log of 2 divided by 2 log of 6. But of course, we can see that 2 is common. We can cancel them out. And if we do, we will remain with a being equal to log 2 over log 6. And choosing to use base 6, we can write that as log to the base of 6 of 2 over log to the base of 6 of 6. Now, we also know that if you have log of a number a to the same base, then that is equal to 1. So log to the base of 6 will become 1. So a will now be equal to log to the base of 6 of 2 over 1, which is log to the base of 6 of 2. So this becomes our solution, our answer. And of course, if you like, you can go ahead to evaluate log to the base of 6 of 2. And if you do that, you will get 0.3869.